Hi, welcome to Module 3, Stress Concentrations and Design. Now I bet you've probably studied stress concentrations in the past, especially if you have a mechanical engineering background. This is often the topic of an undergraduate mechanical engineering curriculum. And we're not going to go into exhaustive detail on stress concentrations. We're going to look at the material-specific aspects of stress concentrations and how they affect the use of materials in design. So we'll do a brief overview about the types of stress concentrations you might encounter in design. And the main concern with stress concentrations is that they will initiate cracks that can propagate to brittle failure. Now the difference between this module and module number 2 on fracture mechanics is here we have stress concentrations that are caused by aspects of the design itself, like a keyhole in a shaft, for example, or a shoulder on a shaft, or a screw hole in a plate. Okay? In Module 2 on fracture mechanics, we talked about stress concentrations around unintentional cracks, not the things that we put in as part of the design, but the natural cracks that occur in materials as a part of manufacturing. So now we're moving to a slightly bigger scale, but we'll have a lot of the same concepts. We're still going to talk about stress intensities, but now we're going to talk about stress intensities that are caused by actual stress concentrations in the design or the geometry of the part itself. Okay? So once you look at the different types and you recognize how to calculate the stress concentrations using standard tables and figures, we'll then look at the effects of things like the type of loading. Is it a static loading or a fatigue loading? Because the effective stress concentrations are different under static loading than they are under fatigue loading. In fact, somewhat by surprise, the effective stress concentrations under fatigue loading sometimes are not as severe as you might predict under a monotonic or single type of loading event. Why this occurs is directly related to the material microstructure. So an important takeaway here is not just the aspects of how to design around stress concentrations, but to understand the material microstructure and how it affects the performance of stress concentrations in a part, particularly under fatigue loading, and to be able to explain and predict what you expect under fatigue when you have a stress concentration involved in your design. Finally, we'll look at sort of the relationships among stress concentration design factors, the monotonic case, the fatigue case, and what happens when you have multiple loading axes and things like this. So this will incorporate into the other modules, both the fracture mechanics as well as the modules to come on things like multi-axial failure criteria.